We are now going to talk about the ref log. We've mentioned it once or twice already. It's a useful tool to know about. You probably won't use it often, but when you do need it, it can be invaluable. What is the ref log? The ref log is a history of everywhere a particular ref has been. Every time Git moves a ref, it gets logged in the ref log. This means anytime you create a commit, rebase, merge, etc., Git creates a log entry. The ref log is a local thing. It doesn't get pushed to other repositories or anything like that. To view the ref log for a particular ref, just type in get ref log and the name of the ref. As you can see, if you don't supply one, it defaults to head. The ref log lists the abbreviated hash for every commit that the ref has pointed at. It also has a shorthand that you can use to refer to that commit, i.e. head, at, curly brackets, and then a number. It also contains the command that was used to move the ref there and the first line of the commit message. Note that the most recent action is at the top of the log. Viewing the ref log via the get ref log command shows you a chronological history of everywhere a particular ref has been. Sometimes, however, going through the log can be tedious. Sometimes it is easier to view things graphically. Passing -- ref log to our get graph command will graph every commit found in the ref log. You're trading the historical time-based view for a commit graph-based view. Why is the ref log useful? Well, there are a couple cases where we can make use of it. Sometimes you might decide you want to undo a reset command, or maybe you want to undo a rebase, or sometimes we might delete a branch and then change our mind. In order to undo any of these actions, you need to know the commit you were on before you took that action. That commit may not show up in the commit graph, but the ref log will have it. Let's look at some examples. Let's look at undoing a reset. First, here's the setup. We have a repository with 4 commits on it. We're going to reset the head back 2 commits. Now to undo this, all we have to do is set main so it points back to D. We know how to do that using the reset command. The problem is that we can no longer see commits C and D in our normal graph. In this trivial example, we can just scroll up the page and grab the abbreviated commit hash from up above where we ran the get graph command previously. But what if we can't do that? How would we find the commit hash for D? Well, we can use the ref log. Here you can see that the most recent action in our ref log is the reset command we just performed. You can also see that just before that, head at brackets 1 is pointing to commit D, and that is where we want to be. So we just reset to head at 1, and we are right back where we want to be. Now let's look at undoing a rebase. I know we haven't talked about rebase much yet. We'll do that shortly, but see if you can follow along. So here's the setup. We have a repository set up like on the top left here. We have a feature branch with 2 commits on it, and main has 1 new commit on it since the feature branch was created. So if we rebase feature onto main, it will create this nice linear history for us that we see in the bottom left. Now it should be noted that commits C' and D' are different commits from C and D. They have different hashes, even though they introduce the same changes. Now, to get back to where we were, again, we have to use reset to reset our feature branch back to D. But once again, the original D does not show up in our normal graph anymore. Here again, the ref log can help us. If we look at the ref log, we can see where our rebase started. We just need to reset to the commit before that. In this case, it is head at 4. Resetting to there puts us right back where we were as if we had never done the rebase. Occasionally, you might delete a branch and then decide that you want it back for whatever reason. The normal command to delete a branch is get branch -d and then the branch name, and the -d is a lowercase d. Get won't let you simply delete a branch whose changes have not been merged into another branch yet. You'll get a warning instead. You'll see in this example I had to use a capital D to override that warning. Git is adding this hurdle to prevent you from accidentally losing data. But now we've deleted our branch, how do we get it back? Recovering a deleted branch is a little trickier than the other scenarios we went over. The normal ref log shows us where head has been and gets updated every time it moves, but deleting a branch doesn't require moving the head, so there's no specific entry in the ref log for when we deleted that branch. If you remember the commit message, you can use the ref log along with grep, and you can search for the commit message. If your head has been at that commit at some point in the past, it will show up in the ref log. That works, but a better way is to pass --ref log to our git graph command. Here you can see that I also have some other commits floating around from some previous examples, but you can find commit D where we want on our feature branch. And once you find that hash, you can just recreate the branch at that commit using the git branch command. That will recreate the branch without actually moving your head there. It just creates the branch reference. We've used the term orphan commit a few times already, but what exactly does that mean? To figure out which commits are orphaned, Git starts at each reference. That was all the tags, branches, your head, and any remote tracking branches. Git traces back through all the commit's parents all the way back to the initial commit. Any commit that is not touched is an orphan. So in this case, all the pink commits are orphans. How do we end up with these orphans? Well, any command that alters history, such as rebase or reset, will produce orphans. And also, deleting branches can produce orphans. So the reason we care about orphan commits is something called garbage collection. So orphan commits are a normal part of using Git. However, over time, they start to take up a lot of space. And often these orphan commits are completely unneeded. You rebased or reset because you intentionally wanted to change history. You wanted to get rid of that data. So to save space, Git garbage collection, or Git GC, periodically goes through and deletes all the orphans. When that happens, that data is gone for good. If you type in git help GC, it will open up a help page and it'll tell you all about garbage collection. Git runs Git GC on its own at certain key times. You can also run it manually. There are a whole bunch of factors that determine when garbage collection gets run and what gets collected. Git cleaning up after you is a good thing, but sometimes you make a mistake and you want that data back. This is where the ref log comes in. The ref log is intentionally there to prevent Git garbage collection from immediately removing orphaned commits. Git GC by default ignores anything that is referenced by the ref log. That's great in that it keeps orphan commits around so that we can recover them. However, we run into the same problem as before. If we keep orphans around, then they take up unneeded space. So the ref log has some expiration settings, so eventually entries will expire and then those commits can be garbage collected. There are some settings for that. Google and Git help can tell you what you need to know about that. Basically, I don't mess with these settings. What you really need to know is that if you have an orphan commit that you want to recover, do it as soon as you realize you need to. And don't run any unnecessary commands until you've retrieved it, because they may trigger garbage collection. Sometimes we intentionally want to get rid of commits. For example, perhaps we accidentally committed a really large file, like a data file with several gigs in it. Or maybe we committed a sensitive file that contains some passwords. We don't want those floating around in our Git repository. So we do a reset to undo that commit. But that commit and its contents are still floating around. So first we have to expire the ref log with git reflog expire --expire equals now --all. That will expire everything in the ref log. If you look through the help, you can figure out how to expire just individual entries if you want to do that instead and keep the others. Then you can run git GC manually and it should remove that commit and its contents. There is another command worth noting, and that is git filter -branch. This is for when you want to remove not a single commit, but say somebody checked in that file, that large file, or that file with passwords, and it's been in your repository for a while, and so it shows up in several commits. Git filter branch will let you go back through those commits and get rid of those files. if you run into that situation, you need to use that, just Google it and that should point you in the right direction. Of course, after you run the get filter branch, then you still have to expire the reflog and run garbage collection. Okay, so how can we find orphans? Well, we can find them if we draw out the graph and trace all the refs down, but that's kind of a pain. We can use something called getFSCK, that stands for Get File System Checker. If we pass that command --onReachable, it will find all unreachable commits. We also need to add the --no-reflog so that it shows commits that are otherwise orphaned but show up in the reflog. So it'll ignore anything in the reflog. So it will show up in the commands now as unreachable. Notice, in addition to commits, we also have orphaned trees and blobs. Trees and blobs are how Git stores data internally. Trees are equivalent to folders and blobs are equivalent to files. Just like each commit has a reference to its parent commit, it also has a reference to a tree. And that tree is the file structure, and it references other trees and blobs, which then those trees also reference other trees. Just like we can start at each ref and trace back through all the commits, we can also trace back through all the trees and blobs. An orphan tree or blob is unreachable from any of our references. So how do we end up with orphan blobs? Well, here's a common scenario. You can see at the beginning that we have nothing orphaned. Then we create a file hello.txt and we add it. At that point, Git creates a blob for that file. But then, before we commit, we reset, which undoes any working copy changes and clears our staging area. As you can see, that blob is still there. To view the contents, we can use git show and the hash of the blob. You don't need the whole hash, you just need enough characters so it's unique. If you wanted to recover it into a file, you could do git show the hash and then a greater than sign and then the name of your file, like recovered.txt or something. This also works for binary files. So if your blob is a VI, git show is just going to give you a bunch of gibberish. But if you then save that off to a file and name it .vi, you can open it in LabVIEW and it will open up your VI just as normal. So if you ever end up in a situation where you've lost a file and you can't find any of your commits or anything, but you're pretty sure that you added it to Git at some point, even if you never committed it, you can recover it if it's been added and in the Git repository.